which is bigger? We're going to have the applausometer again. Okay, how many of you think the number of flakes in a 4-inch DC region-wide snowstorm, you think that's the biggest? Or the amount of snow by kilograms that falls on the entire Earth in a year? Give it up if that's the biggest. The number of atoms in a snowflake, give it up if you think that's the biggest. Because it's chemistry class and you've learned that atoms are super small, a lot of people go for that option down there. What makes it hard to decide? There's a lot of zeros that are tough to count. Okay, Ellen is the only person trying to write all that down. Makes it a little bit easier to see when I put the commas in there. What would make it even easier? No. Scientific notation. Now, if you look at these numbers, how many people think this one's the biggest? How many people think this one's the biggest? How many people think this one's the biggest? Okay, it's this one because it's 4 times 10 to the 18th. That is easy to see once the numbers are in scientific notation. Big numbers are super hard to deal with when they're in regular crappy notation. Okay, this sort of stuff or even this sort of stuff. Really hard to look at and compare. You can compare so much more easily when they're in scientific notation. So the title for today's notes is I Heart. What do you think it's going to be? That's right. Scientific notation. Okay, we're putting the fun in scientific notation is what we are doing today. And putting the fun in scientific notation. All right. 3, 2, 1. Here, there's the sources from my previous thing. All right, write these two numbers down. 3.0 times 10 to the 32nd and 30000000000. Okay. So, as you're writing them down, which one is easy to write down? The left one. Which one is making you scrunch up your faces in funny ways? Okay, the right one. Which one is actually bigger? The first one is actually bigger. Which one? Oh, come on, smartboard. Settle down. All right. Which one is easier to write? Scientific notation. Which one is more prone to mistakes? The same one. What do we love? Scientific notation! Because it avoids these mistakes. Okay, so now that we know that we want to master scientific notation, that's going to make our lives better. Let's write these two numbers down. 590,000 and 0.000058. Go. And now write them in scientific notation. If I catch anybody comparing to the person next to them, they might get a clementine. Teddy, what do you and Amelia agree this would be in scientific notation? 5.9. I agree. 5.9 times 10 to the 5th. I'm doing this. So 1, 2, 3, 4, 5 places to generate that number. Okay, that's why we're reviewing. All right. Gemma and Jackie, do the two of you agree on this one over here? Sounds like a no. Sounds like I'm not super confident. I'm glad we're doing some review, Dave. You're welcome. Hey, Gemma, do you want to take a shot at that, or should I move on? Didn't get to that one yet. Go ahead, Zara. 500 times 10 to the negative 1, 2, 3, 4, 5. So we want to have one non-zero number in front of the decimal. Yo.
Why does it have to be? So it has to be 5.9.
It should be. You don't want it to be 59 times 10 to the 4th because there's still 10s in 59. You want to get them all over there. Okay. Let's do a little more since this is seeming kind of sketch. Go ahead and write these two down. 750 and 0.05. Discuss those with your homie. I would consider it a victory for this class if George and Chase left us homies. So, if they're like, for the rest of the year, there's your homie, that would be really building the community.
I got 7.5.
Jackie, talk to me. Let's work through some of this uncertainty. What's that going to be? To the, how many places do I have to move the decimal? 2. 7.5 times 10 to the 2. Alice, 0.05 in scientific notation would be 5 times 10 to the minus 2. So moving the decimal 2 places in order to make that number. Those are all the smiles I was hoping for. So let's talk about this one. 78.4 times 10 to the 4th. Write that down in your notes book. What do we not like about that scientific notation, Liam? We don't want to have 2 numbers for the decimal. 78.4 contains powers of 10 in it. We want to put all of our powers of 10 together over here. I'm going to teach you a technique for doing this that we're going to do in class today that makes it easier, I think. I'm going to take 78.4 and I'm going to write that in scientific notation. Ava, what is 78.4 in scientific notation? 7.84 times 10 to the 1st. Then I'm going to combine my powers of 10. Right? I have this times 10 to the 4th that was out there. When I'm multiplying the bases, Zach, what do I do with the exponents? 10 to the 1st times 10 to the 4th is? Adam. So it's going to become 7.84 times 10 to the 5th. Smile and nod. Okay, so we are taking the 10 out of here and we're putting it with its buddies, the other 10s over there. And let's try it again. Write these 2 numbers down. 6,024 times 10 to the 9th and 0.078 times 10 to the 14th. And then talk to the person next to you about improving the scientific notation. Go. Again, I encourage you to write each number to its own scientific notation and then combine the scientific notation part. So move it a couple times and write that in scientific notation. That's going to be 7.8 times 10 to the minus 2. And then that's times 10 to the minus 4 times 10 to the 14th. And then put those 2 together. Eli, what is 6,024 in scientific notation? Times 10 to the? Just, you're doing too much. I want just 6,024 in scientific notation. How many places do I have to move the decimal here? 3. I had to move the place 6.024 times 10 to the 3rd is what 6,024 would be. Lauren, I'm now going to combine that with 10 to the 9th, the other part of that number, and what is the final result going to be? I agree. Ellen, what is 0.078 in scientific notation?
7.8 times 10 to the 2.
Correct. And then I'm combining that with 10 to the 14th. Okay, let me go to the back. Carlos, what is 10 to the minus 2nd times 10 to the 14th going to give me?
12.
Correct. 10 to the 12. So this is going to be 7.8 times 10 to the 12. You guys want another round of this? Some yes, some no. Let's do one of these two. Let's do this one. 0.37 times 10 to the 26th. Turn that into proper scientific notation. The other one too won't hurt. Do both. Or you could erase furiously. So we waste your time. Liam, what am I gonna do? Give me an answer and then just jump to the end, dude. What do you got? 3.7 times 10 to the 25th is great. I had to make this 1 power of 10 bigger. So I'm borrowing a power of 10 out of 10 to the 26th. Taking one of the 10s out of there, dropping it down to 10 to the 25th. It's not nodding? Yes, sir.
What if it's like 0.2673?
Would you just
try and put make it 2.673?
Yeah, you'd move that 2.673. In that case, you don't have to use scientific notation. That's not a huge savings. But if it was this, and you'll come up with these examples, times 10 to the 15th, you'd then say, oh, this is the better way to answer it. One non-zero integer for the decimal. Negative exponents are a little harder. Go. I think picking up your pencil is going to be the good first step here.
Oh, wait, never mind.
Because I already redo them anyway. So then I like to save as much paper as I can. These are just my draft notes.
Noah, what's 854 by itself in scientific notation? Correct. Rosalind, if I combine 8.54 times 10 to the second with 10 to the minus 24, what do I get as my final answer? Nope. If I'm multiplying the bases, I just add the exponents. 2 plus negative 24 makes negative 22 is correct. Glad we're getting this time to work this out. All right, and Cole, what is 0.0037 in scientific notation?
3.7
I was hoping that we could involve the whole class in this learning process. You're supposed to just give me this term and give Desira a chance to have the moment where it finish the problem. All right. So this term is 3.7 times 10 minus 3. This is times 10 minus 29. When we combine those two together, hopefully the root's not going to fall in, and we'll be able to answer this question as 3.7 times 10 minus 3, 2. None. The meteorites hit the Earth every day. You're welcome. 3, 2, 1. You guys want one of these, none of these? What do you want?
None of them.
You guys are feeling all right on this?
Yeah.
Okay. We need to talk about how percentages work. Take out your calculator, if you have one, and put in 5 to the 63rd power into your graphing calculator. Yeah, you can share yours with Liam since he is your partner. I know he has a weird head thing, but share with him anyway, okay? just wants to feel safe and warm. Okay, so when you put this into your calculator, what does it spit out at you? Okay, stop. That's enough. All right, so it gives out a whole bunch of gobbledygook. Okay, is 5 to the 63rd power going to be a big or a small number? A big number. But is this a big number?
Not yet.
No. What's the problem? Yeah. At the end of a long series of numbers, you can totally get in the habit of ignoring. They sneak a letter in. Okay, there's a bunch of gobbledygook and then E44. And it would be nice if they had like a space or two before the E, but often it's like easy to miss, okay, on some calculators. And so therefore you have to know that E stands for exponent on 10. So that they're saying this is 1.08 times 10 to the 44th. Write these two numbers down. 1.0842 E44 means, in the words of this one company in Texas that makes computer parts, it means 1.08 times 10 to the 44th. When they first developed these calculators, they could not get them to do a superscript. Their output was so simple that they had to do it all in one line, and that was their system for doing it. Okay, Carlos. Yes. Sam, can you help Carlos with the calculator operation piece of that? When they first developed these calculators, they were too big to fit in a pocket, and they got their salesmen's, like they got a tailor to make extra wide pocketed shirts. They'd be like, look, it fits in a pocket. I mean, they're like confident that within 6 months they would make them small enough that they could fit in the pocket, but like, technologically they couldn't do it. So they had their salesmen lie and be like, look, it fits. Special shirts. Do 10 Rocky. Do you need a calculator? Do 10 to the 3rd times 10 to the 5th. Teddy Rocky, what's 10 to the 3rd times 10 to the 5th? Oh, he's going to the calculator. Teddy, don't do it. Teddy, stop doing it. Don't do it. What is that, dude? 10 to the 8th. My point is that you don't need a calculator for that operation. Amelia, what is 10 to the 8th divided by 10 to the 4th? Say again louder. No. Maybe we do need to talk about this a little bit more. Okay? If I'm multiplying the bases, what do I do with the exponents, Amelia? So if I'm dividing the exponents, what do I do with them? Subtract. So it's 8 minus 4. 4. Okay. 10 to the 32nd divided by 10 to the 8th. And let's mix it up a little bit here and do 10 to the minus 8th divided by 10 to the minus 3. Go. Carlos, question or answer? We're going to discover this in a moment. I appreciate your excitement for the second one. We're going to get there. I'm going to call on you for the second one, okay? But right now I'm going to have Gemma answer this first one. Gemma, what do we get from this one here? 10 to the 24th makes sense. Carlos, what am I going to have if I'm doing negative 8 minus negative 3? That's going to be? Yeah, that makes a plus, so that's minus 8 plus 3. Okay, but why? Because you're right, negative and negative makes a positive here. Negative 8 plus 3 makes negative 5. Okay, this, it's negative 8 minus 3. Negative 8 minus negative 3, the two negatives make a positive. Negative 5. Let's do another one. Okay. I think we're not solid on this. 10 to the 7th divided by 10 to the 13th. 10 to the negative 7th divided by 10 to the negative 21st. Go. Trying to make them as wicked as I can. Here are some weird negatives and stuff. So it is -7 minus -21. What's negative times negative makes this one? So it's -7 plus 21. Jackie, what is 10 to the 7th divided by 10 to the 13th? Correct. 10 to the -6. Ava, what is 10 to the -7th divided by 10 to the -21? 10 to the positive 14th. Better, hopefully, a little bit. Okay. Which part of this needs a calculator? 10 to the 4th times 10 to the 3rd, or 4.2 times 1.5? Which one do we need a calculator for? First one. This part you could do in your brainulator. Okay, what is 10 to the 4th times 10 to the 3rd? 10 to the 7th. What is 4.2 times 1.5? Look at your calculators, figure it out.
Is it like 5?
That's right, 6.3.
I didn't know that, dude.
Because I've done this problem before. So, don't get scared and thrown off when you see this problem here. When we see this problem here, you would think like, oh, I got to type all this crap into my calculator and go all the way through. But you don't want to do that. You want to say this part, I'm going to do it on my calculator. 4.2 times 1.5 is 6.3. And then this part I can just do in my head. 10 to the 4th times 10 to the 3rd. 10 to the 7th. Without putting it all in, if you get along two scientific notation numbers and you're multiplying by each other, I would recommend multiplying the number parts on your calculator and doing the exponent parts in your brainulator. It's going to be faster than it would be to type all of that stuff in. Do this problem with the person next to you. Go.
Solve it like the whole thing.
You're done. If you have a number and a notation, you're okay. Zach, what does the calculator say 3.5 times 2.8 is? Say again? 10.15? I don't think so. Check it in. 3.5 times 2.8. 9.8. Eli, what is 10 to the 20th times 10 to the -20th times 10 to the 5th? 10 to the -15th is correct. Smile and nod. Right? It's easier. It's faster to not use your calculator for this. To do what it's picking the right tool. Like if you're golfing, you have a long driver. That's a different tool than like a wedge or something like that. Depending on what tool you need for the situation you're in. Go. 4.4 times 10 to the negative 14th, 1.6 times 10 to the 3rd.
No, would you? See your present?
Yes.
Really?
Big, you get frisbee, it's all the same thing. Okay. I don't know where I am, so I'm going to start. Oh, I'm over here. Lauren, what is 1.6 times 4.4?
7.04.
7.04. And what is 10 to the negative? That's what I want to do, smartboard. No. What is 10 to the minus 14th times 10 to the third?
10 to the negative 11.
All right, Trace, you're the king. Here, you can prove it. What is the answer to this would be without looking at your calculator? You don't need your calculator this because the number portions are the same. What would this one be?
7.3 times 10 to the 8. No.
I'm adding 14 and 6. They're both negative. Negative 14 plus negative 6 adds up to negative. You're subtracting. You're trying to subtract. It is just 14 plus 6, dude. He's got, he's got conviction there. He is not just going to change just because someone told him it was wrong twice. He is going to hold on to his belief. That's fine. It's good to have that kind of conviction. All right. Let's divide.
Wait, no.
Georgia, what's 3.4 divided by 1.7? We're going to say 2.0 to kind of keep our sig figs going. And then Isabel, when I divide, what do I do with the exponents? So what is 10 to the 8th divided by 10 to the 3rd? 10 to the 5th. If you put this into your calculator, it could give you the wrong answer. This is the most common mistake with this stuff. I'm just going to write it out here and say 3.4 times 10 to the 8th divided by 1.7 times 10 to the 3rd. Your calculator will often say 2.0 times 10 to the 11th. What has your calculator done? Why?
It automatically did it for you.
Because it follows it in order of operation. Your calculator, if you put this in your calculator, it's going to do this number divided by 1.7, and then it's going to take the answer from that. It's going to take the answer. It's going to take the answer from that and then multiply that by 10 to the 3rd. So what do you have to do to keep your calculator from making that mistake? Use parentheses, or just do it in your head, like the way I taught you. Do this part on your calculator, do this part in your head. It'll probably be faster anyway, and you don't need to worry about making sure you put parentheses here where they actually belong. That's a very common mistake with like calculator entry.
Wait, where did the parentheses go?
The parentheses would go around the second term only. Let's see if I can erase this. This is the one I need. That is the best way to do it. Or, as Sam Tyler and I are begging you to do, use your brainulator. That's what it does. You can do 10 to the 8th divided by 10 to the 3rd without having to get your fingers all stuck in the calculator. 3, 2, 1. Go. Like halfway, have more to do. Yeah, we're going a little slow, but we're going to do it. Okay. LC, what is 14.7 divided by 3.5? Never mind. Teddy, what's 14.7 divided by 3.5? Say again. 4.2. LC, what is 10 to the negative 3rd divided by 10 to the 4th? 10 to the negative 7th. Smile and nod. I have rigged these a certain way that you're about to discover when you encounter one that is not rigged that way. Go. Liam, write that problem down. Bless you. Amelia, what does your calculator say 6.8 times 4.1 is? 27.88. Okay. Gemma, what is 10 to the second times 10 to the third? Nope. Nope. Fifth. We just add those numbers up. What's wrong with this picture, Jackie? So now we have to use the stuff we did at the beginning of the class and clean up the scientific notation. Often when you do a multiply or divide, you're going to get something that isn't clean scientific notation, so you have to take that step that we already practiced and clean it up. Okay? Alice, what do we want to turn this into? Times 10 to the 6th. I'm making the number part smaller, so I have to make the exponent part bigger. I'm moving the power of 10 over there. Go. It's really funny, Liam. Tell Sam first, just see if it's funny for you to distract everybody else. Okay. So, where am I here? Ava, what is 4.4 times 5.6? 24.64. Rosalind, what is 10 to the minus 14th times 10 to the third going to give me? Negative 11. All right. Noah, I got to take 1 power of 10 out of here. I'm going to make this 2.464 times 10 to the first. I'm going to multiply that by 10 to the negative 11th. What is that going to give me? This one is maybe worth writing out the steps and like peering under the hood for because it's confusing because it's a negative exponent. A lot of people think, oh, I'm making this smaller to make this bigger, and they make that 10 to the negative 12. 10 to the 12th is actually smaller. It's a more negative exponent. So showing the step, showing the 1 here, can keep you out of trouble. When, in God's name, will we ever use this stuff? Let's do one sample problem here. How many years would Dave have to work? This is what I look like. That's a symbolic representation of me. Okay, to make as much money as Bill Gates makes in a year. Okay, I make 97,000. 1,000 is 10 to the third. Okay, how much is a million? 10 to the sixth. How much is a billion? 10 to the ninth. So Bill Gates makes 111.5 times 10 to the ninth. So we want to figure out how many years I would have to work in order to make as much money as he makes in just 1 year. We're going to divide those. We're going to do 11.5 times 10 to the ninth divided by 97 times 10 to the third. Go. Liam, what does your calculator say 11.5 divided by 97 is? 0.118. Okay. Carlos, 10 to the ninth divided by 10 to the third is 10 to the sixth. Is that pretty scientific notation, Cole? No. What do I want to turn it into? Times 10 to the... Nope. All I did was I'm borrowing 1 power of 10 out of here in order to get this to be like 1 power of 10 bigger. So that's going to be 10 to the 5th. 10 to the 5th is 100,000 years. I would have to work about 120,000 years to make as much money as Bill Gates makes in 1 year. Humans have existed as a species for around 150,000 years, okay? Like the time of the Bible was 2,000 years ago, I would have to work 60 times longer than that in order to make as much money as Bill Gates makes in 1 year. I guess I should have studied computer science. All right, so you probably want to practice this in the comfort of your own home. I've got the perfect thing by which you can get better at this sort of skill. You're welcome. Oh, no, you don't have to do that. It's cool. It's just what I do.